Hello everyone, welcome to the series tutorial on image processing using MATLAB. For getting started with MATLAB, I will recommend you to refer my previous videos on introduction to MATLAB. Now let's get started with this. First thing, image processing can be defined as the analysis and manipulation of digitized image in order to improve its quality. It means we work on image pixels to change and improve its quality or change its properties. Application area of image processing can be something like medical field, transmission and coding, machine vision, robot vision, color processing, pattern recognition, and several other applications areas are in which image processing is being used dominantly. Now let's start with it. So what we'll be doing in this tutorial is we'll first try to learn how to read an image into MATLAB, and then we'll do an operation like adjust the contrast of that particular image and write the changed image or enhanced image to the file. Alright, now let's get started with this. So for reading any image we need to declare a variable. Let's declare a variable I equals to, now the command that we use to read image is I am read, then into small brackets we need to give the address of image. Now let's say I want to read this particular image on my desktop, tulips. So what I'll do is I'll right click on that, go in its properties. In property I can find the location of image, this one. I'll copy the location. The name of image is tulips.jpg. Then I'll go back to my MATLAB. Here I have to paste the address, so I have, and then the name of image is tulips.jpg. Alright, so done. See, now I have a variable in my workspace with the name I, which is having value 768 into 1024 into 3, and it is of type unit 8 image. Alright, so this is the type of image. Now let's work on more into it. Alright, so now let's first see the image. So it is, we can use the command I am show. The name of image is I, so it would be I am show I. So we can see the image, it has opened MATLAB window, and this is the image we are having. Now for like analyzing image, again there is one more command that we can use, is I am tool. IM tool is again similar command. The difference between IM tool and IM show is, in IM tool we are having several other functionalities like image information tool, pixel region tool, contrast adjustment tool, etc. Like you can see over here in down we are having the it is this one. In down we are having the value of X, Y, RGB. It means as soon as we move our cursor anywhere into the image, it is showing us the value, the number of pixel in row wise and column wise, and the value of R, G and B on that particular color. It means as soon as we move our cursor on red color, it is showing the maximum value of R and minimum value of G and B. Similarly on green color, it will show the maximum value of G and minimum value of R and B. Similarly on blue color, the maximum value of blue is there. So this is how we analyze the image and its pixel values. One more thing that we can do is we can write who command, and it will tell us which of the variables are declared. Alright, so and if we use this particular command whose, then it will WHOS, then it will tell us all the properties of that particular variable as well. So whose I, and it is having size of this much and byte this much and class is unit 8. Alright, MATLAB can store images such as unit 8, unit 16 or double arrays. Let's open any other image into MATLAB using declare any other variable. I1 equals to I am read part.tif. Should be into single inverted comma because it is the address of image. So it is pout.tif image we are going to open into the MATLAB. This is a pre-stored image into MATLAB, so we can we need not to put its address. Alright, so you are having I1 image, which is a grayscale image. That is why it's in its size you can see there is no 3 because it's a unidimensional image. Alright, now let's open the image using imshow command. So the name of image is I1, so I will open I1, and here we are having this particular image. You can see this image is having very low intensity. It is a grayscale image. It means it is having a single color, white or black, and intensity of white and black is changing rapidly. Now let's analyze the intensity of this particular image. So for analyzing intensity of any image, or for analyzing the distribution of intensity in an image, we can use Hist command. So let's use Hist. Let's store that particular image into a figure variable. Hist of image I1, and here we can see the distribution of intensity over the range 0 to 255. Why 255? Because it is of unit 8 type image, and the maximum value can go 2 to the power 8 minus 1. So we can see the intensity of the image is distributed very narrowly. I mean, the intensity range is very narrow. It means the image is not having values into this particular range around 160 to 255, and into this range 0 to something 75. So if we just spread the intensity range over the full spectrum 0 to 255, the image will be having high contrast. Now let's do this. So to spread the intensity values over the full range of image, we can use a command called hist eq. So let's store into another variable hist eq, and the name of image of ours is I1. Alright, now sorry, it is, let's declare a sequential variable, so it is I2. Alright, now it's done. So we are having now I2 image as well. Alright, now let's analyze this particular image. imshow I2, and we can see this image is having very high contrast and very high intensity as compared to the earlier image we were having. Let's open the earlier image as well, so that you will be better able to analyze that particular image as well. Alright, so imshow we are having the first image, and then in figure window let's open imshow I2. So sorry, it is wrong. It is imshow. So here we can see we are having both of the images, and this particular I2 image is having very high intensity as compared to this. We can even analyze its intensity range using again hist command. Figure hist I2, and we can see the intensity of the image is spread over the full spectrum starting from 0 to 255, and the maximum intensity values are in between this particular range around 150 to 255. That is why the image intensity is very high. So this is how we can analyze images into MATLAB. Again, if we want to convert a particular type of image into a particular type, let's open our image I, which is imshow. Now let's open our image I, which is imshow I. So we can open it using this particular command, and we are having this particular image as this one. Alright, now this is an RGB 3-dimensional image, RGB image. If we want to convert this particular image into unidirectional image as a grayscale image, we can use a syntax called RGB to gray. So we can declare a new variable I3 equals to RGB to gray, and into that the input argument will be a real image, that is I. So here we are having I3 image as well. Alright, so now if we want to see the image, we can use im show i3 and we are having a grayscale converted image. Alright, now if you want to convert this particular image I into black and white format, then we can use another command called im to bw. So it can be something like this: i4 equals to im to bw I, and this would convert a new logical variable i4 because it is a logical image having the same size. It is not unit 8 type image. It means its intensity value is not varying. We can see the image. I am show i4. So here, either it is white, it means either it is 1, or black, or 0. So this is how it is called as logical image or black and white image. Thank you very much for watching out this video.